All right, students, welcome back to another new day of Unit 7, Part 2. We the other day we just finished Newton's laws, and today we're actually going to begin talking about the moon a little bit, getting some more space stuff. So I'm excited. But first, let's quickly review. Again, next week we'll have our online tests and notebook checks. We have our writing assignment that's already been posted, so make sure to get ahead and stay up to date on that stuff. Where we got number 1. For page 8 or 8B in your notebooks, again, I've got a limit on time today, so I'm going to go a little quick here on this prior recorded lesson. Okay, hopefully you guys can see me okay. We've got number 1, what are Newton's second and third laws of motion? 2, what two factors determine the gravity of planets? And 3, what is centripetal force? Centripetal force. Let's go ahead and check those out. Okay, number 1, Newton's second law, force equals mass times acceleration, right? So again, you have to have a lot of, the force of something is going to depend on the size of it, as well as how fast it can move, right? So kind of like we see with a lot of machinery, trains, or even animals as well. The more mass and the more acceleration, the more force it will pack behind it. Then number 2, third law, that is, so number 1, to every action, there is an equal and opposite reaction. So like we see on the skateboard there, right? If you, kick your foot off the ground, that's the action on the board. The reaction is the board moving forward. So to every action, there's an equal and opposite reaction. Number 2, guys, we have planet distance and mass. Those determine the gravitational force of an object. So the farther the planet is, the less gravity it has, based on its movement in our solar system. But also, if it's larger, the planet itself on the planet's going to have more gravity as well. So for example, if you're on Jupiter or you're on a larger planet and it was rocky, it wouldn't feel too great. It would probably, crush you to the ground. Again, so for example, if Earth was larger, that would probably be a bad thing, right? It would make the comfortability of being on Earth would be much less. Trees would be shorter. Our bones would have to be stronger. It'd be a tougher place to live. And then lastly, number 3, centripetal force is the inward force causing an object to move in a circular path. So kind of like we see right here. Okay. The gravity of the sun is going to create the centripetal force of our planet to move kind of in a circular fashion. It's not perfectly circular as we know, though. It's going to be an elliptical. Okay, moving on. Again, pause the video as you see fit. Last update for the table of contents is the moon phases on page 10. Again, we've got moon phases on page 10. Add that as well. And then moving on to our first question. Which term describes the rate at which an object changes position, distance over time? Is it A, speed, B, acceleration, C, velocity, or D, incline? What's that going to be? What's it going to be? The answer is going to be A, speed, guys. Speed, again, the general term, just distance over time. Acceleration is speed given a direction. Velocity is, acceleration is the rate in which speed increases. Velocity is the speed given direction. Let's do our first video questions of the day. Number 1, how does the moon create tides? How does the moon create tides? You can write that on page 8 or 8B. So how does the moon affect the ocean per se? And then number 2, what sun and moon positions are needed for spring and neap tides? Please go ahead and write these questions down on page 8 or 8B, page 8 or 8B if you need room. Pause the video as you see fit. Let's check out our answers through our first video of the day. One moment, guys. Again, going to try to be brief here.
The rules of gravity cannot be changed, but...
One moment.
Kate Wallace has now been missing.
Okay, we got advertisements, guys. My apologies. Again, I've got about 10 minutes here. I'm going to try to be done. Waiting for the advertisement, guys. Waiting for the advertisement to be finished. Okay.
Hey, check out our new TestTube app in the iTunes Store. Download it, give us a rating, let us know what you think, okay? Okay. Hey there, I'm Josh Clark, and in this Brain Stuff, I explain to you how the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown, and wondered, I wonder how tides work? Well, next time you'll know, and you can explain it to that person as they wait to die. We need to be very careful here because, as French astronomer Francois Arago once said, studying the tides is the tomb of human curiosity, which means it can break your brain, as you'll see. There's a lot of factors involved in creating the tides here on Earth, but the big three are the moon, the sun, and the Earth. The gravitational pull of all three of those bodies interacting creates the tides. The biggest factor actually is the moon. It exerts about 2.2 times more power on the tides than the sun does. So for once, the moon gets to one-up the sun. It's kind of a big deal to it. Imagine for our purposes, the Earth is right here and the moon is directly above it. Now, they exert a gravitational pull on one another. And since on the Earth, most things are pinned down, we have shoes, buildings have foundations, stuff stays in place. But the oceans, being literally fluid, actually can be pulled toward the moon. And this is what creates the tide. The moon's here, it's pulling on the ocean at the top of the Earth, creating a high tide on the top. Now on the bottom, another high tide is created because the Earth itself is pulled toward the moon, even though the oceans down here have less gravitational pull exerted on them, being farthest away from the moon. So on the top and bottom, you have high tide because of the tidal bulges, and on the sides that are at right angles to the moon, you have low tide because the ocean's stretched thin over the surface of the Earth. Pretty crazy, huh? So, like I said, the sun also exerts an influence on the tides, but it's less pronounced than the moon's. See, it actually enhances or diminishes the gravitational pull of the moon here on Earth. When the sun and the moon are in alignment, the sun enhances the moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the sun and the moon are at right angles to one another, with the Earth right about here, the sun diminishes the gravitational pull of the moon on Earth, creating lower than normal high tides, also called neap tides. These happen on the quarter moons. Because the Earth and the moon are constantly moving and moving around one another, there's a constant movement from high tide to low tide. Twice a day, you get a high tide in most places, usually once every 12 hours and 25 minutes. But this can vary, and some places only see a high tide once every 24 hours. Those are called diurnal tides. So this is a daily occurrence, actually twice daily in most places. But tidal waves, even though they have the word tide in them pretty much, but without the E, they're not related to this gravitational push and pull. They're usually the result of earthquakes. So that's tides. Hopefully we avoided that tomb of human curiosity and you guys get it. If not, going back and watching it again, there's no shame in that. It's
All right, guys. So
pretty
good
heavy
breakdown there
If you
of
like
some
this
of our
video,
moon-based
let
stuff.
us know. Leave us a comment below. And hey,
All right, so let's get into that because we only have a few minutes left here. What were the details on some of our? Oh, it looks like the screen is stuck here. Okay, so some details we need to know. Number one, how does the moon create tides? It's the gravitational pull of the moon. Again, the moon influences tides more than the sun because it's just closer, right? And then the sun and moon, so again, it's going to be pulling on a part of the Earth, the part of the Earth where it's parallel with the moon. That's going to be pulled outward, which makes those ocean tides because the water's flexible, right? Then we have the sun and moon positions. We're going to get into spring and neap tides. So spring tides, we've got a linear setup. That means we get really high tides or really low tides. And neap tides, it's more moderate, right? So more medium tides with our neap tides. But just know that's for the right angle. When the sun and moon pull in like different directions, like the sun will be up, moon will be sideways. Whereas with the spring tides, it's when they're all lined up in a linear fashion, pulling on the same plane, right? Okay. So cool stuff there. Introduces our topic. What I want you guys to do is set up page 9. Set up page 9. Here's what it's going to look like. Okay. Page 9 is going to be titled Spring and Neap Tides. Page 9. Again, pause the video as you see fit. Pause it as you see fit on YouTube. Okay. You're going to have 3 total categories. 3 total categories. Again, pause the video. Pause the video. All right. Your first category is going to be sun and moon, solar and lunar tides. Sorry if it's not easy to read. All I've got is just a sun and a moon there, just a sun and a moon, nothing too complicated. This is where it gets a little more important and detailed though. And again, on the right side, just leave it blank. The left side, these are where we have the pictures. The pictures are important, okay? And it's where we have the different categories. Spring tides, again, like I said, it's linear. So I want you to draw the sun, the moon, and the earth position in a linear format. So that's the second category, the second column. Okay. And then the last one, the third column, okay, it's neap tides. Again, it's at a right angle. And I label these, remember, full moons when it's behind the earth, new moon when it's in front of the sun. Okay. Neap tide, again, right angles, right angles. And we have, again, looks like a first quarter moon and a third quarter moon. We can see there. So make sure you label each of those. Have the 3 categories for each one. That's going to be page 9. All right. So I'm going to pause the video, go back, pause, draw those. Let's go ahead and continue. All right. So what do we need to know in regard to the moon? Well, we're going to go over one quick category, guys. One quick category. Again, thinking about, again, what are tides? What causes them, right? We now know the moon is a great influence. Okay. How do the moon and sun impact tides? Which impacts more? Like I said earlier, the moon does more because it's closer, right? So I want you to write down on this page, right, on this right here, where it says, actually, yeah, so this is going to be on page 9, where, you know, you could actually have this on page 8 or 8B. Page 8 or 8B would be fine, probably. Okay. But yeah, tides, periodic rise and fall of sea level. We know what they are, but I just want you to have a written down definition for it. And again, high tide, simply put, the highest level to which water regularly rises. Low tide, the lowest level to which water regularly rises. Right? Common sense stuff, right? So if I have time, I'll maybe play my last video here in a second that kind of goes into that a little more. And the last thing of the day I want you guys to write down, okay, is, again, we already set this up. Okay, we've already written that out. Spring tide, they're going to be, again, in a line. Neap tide, we're going to have tides at an angle, Again, the line pulls the tides more than the angle does. Here, the neap tides are weaker. Spring tides, the tides are stronger, more extreme, more moderate, more extreme, right? Okay, last thing of the day, you're going to write this on the top column on the right. The low, high tide, and spring tide, we'll just keep that on page 8 or 8B. That's fine. This, though, this is solar and lunar tides, super important. So lunar tides, the moon has the largest effect despite its small size since it is closer to the earth. Whereas with the solar tide, the sun has a smaller effect despite its large size since it is farther. So you can simplify that if you like, but those are 2 things I do want you to check out and I do want you to write down. Like all that, right? Again, everything we've seen today, we should have written down. Everything we've seen today, right? Okay, so pause the video, get that down. Let's go ahead and get to our last little clip here. Kind of re-emphasizing those tides, right? Just going to play a little quick minute of this. And again, I think it's kind of it's cartoon, but I think it is kind of funny and breaks it down to a simple format.
A particular place. When the sea level rises to its greatest height, it is known as a high tide. And when the sea level drops to its lowest height, it is known as a low tide. Tides are primarily caused due to the gravitational force of the moon. But how? Part of the Earth facing the moon
Here we see this again,
experiences a
right?
stronger gravitational pull towards the moon as compared to the Earth's center. So, the part facing the moon is pulled away from the center, creating a bulge and thus increasing the sea level and causing a high tide.
So again, the planet bulges slightly because of the moon's gravitational pull.
Now, the Earth's center experiences a stronger gravitational force towards the moon than the part facing away from the moon.
And that's high tide, right?
Hence, this part is pulled away from the center, resulting in high tide on the opposite side as well. In addition...
All right, guys, the bell just rang, so I'm going to head out. Stay ahead of your work. This is Mr. Campbell signing out.